Hi, this is Joe. Okay, with this my weekend videos, I would like to show you how you can set up PLC applications on your Raspberry Pi. So Raspberry Pi can not only can use for some low-cost IoT applications, it can also be used for the industrial application using a PLC ladder diagrams or structure text. Okay, to set up the PLC software on the Raspberry Pi, the process is very simple. First, you just go to this OpenPLC project website. Then there are some guidelines for you to follow. Okay, it's pretty straightforward and simple. First, you just have to install the WirePi package. Okay, and followed by install the necessary libraries and packages over here. And next, you have to download the OpenPLC version 2 software from the GitHub. Okay, so after that you just go to the OpenPLC version 2 folder, and then you just build and compile. Okay, the process will take about 20 minutes. Okay, and lastly, the compiler will ask you to select the options. Okay, so for my case, I'm using Raspberry Pi, which is option number 4. Okay, after you have done the compiling, and next you need to download the PLC editor. So this PLC editor is available for both Windows, Mac, and also Linux. Okay, so and next, after you download it, you can start to run the PLC server. So just use this sudo node.js server.js. So in my setup over here, so I'm using Raspberry Pi. I'm remote login using VNC Viewer. So I just go to my folder that I downloaded previously, and then after that I run this Node.js. So this is a hot that I'm working for my PLC server. Okay, next. Okay, in my Raspberry Pi also I've downloaded this PLC editor. So this is a Python software. So I just simply call the Python and followed by the Python editor. Okay, this is the PLC editor. Okay, the layout is quite simple. It is similar to what we have done for the other PLCs. So to create new projects, just create new button here. Okay, then you just have to key in some particular field. Okay, so order graphic. So I will be going through in details. So I'll be going through more details in my Windows side. Okay, Windows also I have downloaded the PLC editor. Okay. Okay, so let me close this. Okay, next, my server is running on, so ifconfig the IP address 192.168.1.104. Okay, so to turn on my server, first I run this Node.js. After that I just click run. So now my status now is running. Okay, and first and foremost I need to program the ladder program. So this PLC open editor, I'm using Windows. Okay, the editor can run either ladder diagrams or the structure text. Okay, to me I'm more used to with the ladder diagram. So this is a ladder diagram. Okay, so in my setup here, I just have to create a program. Very simple, just left click and then click program. So you can have this program. Okay, next for the configurations, just click, you can there's a configuration followed by resources. Okay, there's resources here. Pretty straightforward. So after that you just have to key in some parameters. Okay, and this is a main program. So in the main program is very straightforward as well. Here you have to set up your require inputs and outputs or some functional blocks. Okay, here is a workspace. Okay, so on top you have some editor tools here. There's a power rails, output clock, inputs, variables, okay, and functional blocks, and then connections. Okay, so in my setup I already have a one input button and one lamp. So firstly I need to create a variables here. After that I just click and then drop it over here, and I just assign to my variable. So it's pretty straightforward. Okay, after you have drawn the PLC, so you can just simply save. Okay, next you have to compile and then save it as a ST program, structure text. So in my setup, okay, I just using IOST to save. So the program is compiled and generated. Okay, my program is pretty simple. I'm using a button to trigger the lamp. When my button is on, the lamp will turn on. Okay, so for the I/O for the Raspberry Pi, I have to strictly follow the I/Os that connected over here. Okay, this is a pin out. Okay, so the Raspberry Pi pin, I have to follow, let's say for the input, I have to follow the IX. For the output, I have to follow the QX. Okay, so my buttons IX 1.4, which is number 35, pin 35. So when pin 35 is pressed, I turn on the QX 1.2. QX 1.2 is port number 14, or pin number 14. Okay. Okay, so now, after I've compiled my file, right, I just go to my server, I just go to browse, select the file that I generated just now. After that, I upload the program. Okay, it will take for about 10 to 15 seconds to compile and to run. So now it's compiling, and then okay, a compiling PLC program. Okay, now it's compiled without error. So to give you some visualization, I'm using a NodeRED to visualize and or show you this pin out, which is pin 40. Okay, so basically here in pin 40, I'm showing you the logic 0. So this is before I press the button. So now I press the button. Okay, so you see here it becomes logic 1. So I release the button, it becomes 0. Press the button, logic high. Okay, so that means this OpenPLC can be linked up to the NodeRED, okay, to further enhance or to further develop your IoT applications. So I feel that NodeRED alone is pretty powerful, and combined with this PLC software, it can be much more powerful to build industrial applications. Okay, so don't forget the URL. Okay, this is the one that you can set up your OpenPLC in the Raspberry Pi or many other devices. You just strictly follow the instructions here. Okay, so with that, let me end my videos. I hope you enjoy.